Hello, we are Team 162, and the title of our project is Exploring Deep Learning Techniques for Image Captioning. Our aim is to build an image captioning system with commendable accuracy, and we've done this using recurrent neural networks and convolutional neural networks to provide detailed descriptions for the images. First, we've used CNN to extract rich features from the images, and then we've used long short term memory networks, that are LSTMs, which are a type of RNNs, to produce logical text descriptions that correspond with the visual content. We have used Flickr 8K dataset. There are a few reasons why we picked this particular dataset. We felt that using 8,000 images would give us a sensible trade off between training time and model quality and accuracy. The images were picked from six distinct Flickr groups, and they were carefully chosen to show a range of settings and scenarios rather than any famous persons or well known places. Each image is provided with five distinct captions that are logically coherent with the image. Here you can see each image having five distinct captions that are logically coherent with the image. You can see the top 20 most common words in captions, excluding stop words such as, is, are, the, etc. This is the distribution of caption lengths, and you can see that most captions are between 8 to 15 words. The number of images are 8,091, and number of unique captions are 40,202. Methodology. During data and pre-processing, we have done caption normalization and we have done feature extraction using CNN. And in the model architecture, the encoder has normalization and dense layers, and the decoder there's an embedding layer and an LSTM layer, and output layer has one add layer and two dense layers. During training, the input for encoder are the image features that are extracted from the CNN, and the input for decoder are five captions of the corresponding images. And we use these to update model weights and minimize the loss. We've used greedy algorithm and beam search for inference and used blue score for evaluation of these. Greedy algorithm chooses the most probable word and appends it to the current caption until we can reach the end sequence or reach the maximum caption limit. Beam search maintains multiple alternative hypotheses next words to a caption. This process continues until we reach the end sequence or reach the maximum caption limit. The baseline uses CNN and LSTMs, which are similar to what we use in our proposed model, and it also uses Flickr 8K set, which is what we use in our proposed model as well. The image features are extracted from VGG16, which is a convolutional neural network, and the blue 1 and blue 2 scores are as follows. And this is the baseline output where you can see five given captions and the predicted caption for the picture below. Coming to the limitations of the baseline model, we feel the pre-processing is very simple rather than having a better quality CNN for richer feature extraction. And the blue scores of 0.529 for blue 1 and 0.302 for blue 2 are a little low, and we believe we can improve this by better pre-processing. So the improvements that we've done to the baseline model are we've used Inception V3 model instead of VGG16 as our CNN. And Inception V3 is a little more complex compared to VGG16, but has fewer parameters and lower computational overhead. And we also used early stopping. That by early stopping, the improved model monitors validation loss and stops training if the loss doesn't improve, effectively preventing overfitting and ensuring the model generalizes well on unseen data. Optimizer configuration, we've used Adam Optimizer with a specific learning rate and clip norm in the improved model, which allows for more controlled updates of model weights, which can help in achieving a stable and effective learning process. And these are the results for our proposed model. You can see the caption and the blue scores using different inferences like greedy and beam search. And this is the graph of training versus validation. You can see the difference here. Thank you.